Numerical integration is the approximate computation of an integral. You want to find the value of integration using the numerical techniques. So we just approximate the value. This is not the exact solution. So in this part, we discuss the following numerical integration method. We have three methods. First method is the midpoint rule, also known as the rectangular rule. And then we have trapezoidal rule and the Simpson's rule. So before doing the approximation, we first have to give the number of subinterval that we want to consider and find the length of each subinterval. This is your graph. For example, you have this graph. So basically, numerical integration represent the area under the graph from A to B. This is a definite integral. We have the lower limit and upper limit. So now you want to find the area under this graph fx between A and B. So what is number of subinterval and the length of each subinterval? We suppose that the interval from x equal to A to x equal to B is divided into n number of subinterval, okay, with the same length, where the length of each subinterval is h. So how to find the h? B minus A, this is your B and this is your A, divide by n. So n is the number of subinterval. So this is your h, the value here, the length of h. Okay, now let's move to midpoint rule. In this method, we suppose that every subinterval forms a rectangle, where the height of each subinterval is half times xi plus xi minus 1. So areas of all rectangles are computed and the total area of this rectangle is the approximate area below the curve of the function, which is also the estimation of the integral that we want to determine. Okay, let's say we have this graph fx. So now you want to find the area of all these rectangle. Okay, all these rectangles. Why it is called a midpoint? Because we want to find the midpoint here. Midpoint of all these rectangle. The rectangular rule is given by this formula. Integrate fx dx from A to B, h times f x1 star plus f x2 star until f xn star, where xi star is equal to half times xi plus xi minus 1. This is the midpoint. So the estimation of this integration will be more accurate if we increase the number of subintervals n. So you can see here, if you only have two rectangles, okay, there will be two rectangles and this will be your error. The error will be large, and if you calculate for 8 rectangles, 1, 2, 3, 4, 5, 6, 7, 8, this is the only error, very small error. So that's why you can say that this integration will be more accurate if we increase the number of subintervals n. Okay, so let's look at this example. Estimate exponent negative x squared dx from 0 to 1 using 10 subintervals. N is equal to 10. N is the number of subinterval. A is equal to 0. B is equal to 1. A is your first point. First find your h. B minus A divided by n. So 1 minus 0 divided by 10, 0.1. This is your h. You can write down the value of your xi, xi star and fxi star in the table form. So this is 0, first point, A equal to 0, and the last point will be B equal to 1. I0, xi0, okay, no midpoint, no fxi star, And then for I equal to 1, the next xi will be 0.1 because you just add the h plus h and then plus h, okay, plus h. Okay, h is equal to 0.1. So 0 and then plus 0.1, we get 0.1. 0.1 plus 0.1, we get 0.2. Okay, until you get 1. You have to stop until you get 1. And then this xi star is the midpoint. How did you get 0.05? Okay, half times x1 plus x0. 0 plus 0.1 divided by 2. So you will get 0.05. Similarly, for 0.15, 0.1 plus 0.2 divided by 2. So you will get 0.15. And then fxi star, just substitute this value xi star into your fx. This is your fx, exponent negative x squared. Substitute x equal to 0.05 into this equation. Then we will get 0.997503. Then find this value for each i's. Okay. And then sum up all these values. So from this table, you get this 7.471308 times 2h. The summation, okay, this is the formula. This is equal to h times fx1 star plus fx2 star plus fx10 star. So you get this answer. Okay, you can try to calculate this using Excel. Okay, let's look at another example. Use the rectangular rule to estimate the integration of x divided by square root x plus 1 from 1 to 4 with h equal to 0.25. You don't have to find your h because it's given here. So your A will be 1 and your B will be 4. So from this given value 0.25, A and B, you know that your N will be 12. Okay, H is equal to B minus A divided by N. So N will be 12. Okay, similarly, you have to write down your solution in the table form. So this is I, XI, XI star, FXI star. Point A equal to 1 and point B will be 4. H 0.25. So you just add up 0.25 for each of your xi. And then find the midpoint for x1 star 1 over 2 times 2. 1.25 plus 1, you get 1.125. And then fxi star, substitute this value into this fx. X divided by x plus 1 square root. So you will get 0.771744. So by using the midpoint rule, also known as the rectangular rule, okay, this is your h and this is the summation of your fxi star. Okay, multiply this, then this is your approximate solution. Okay, the second exercise, okay, given this is your fx, this is your A and this is your B, okay, use rectangular rule with 5 subinterval to find the approximate solution. Okay, this is your A and B with 5 subintervals, so your H will be 0.4. Okay, right, in the table form, I, XI, XI star, FXI star, A, B. Find the midpoint. Okay, 0.4 plus 0 divided by 2, 0.2. Okay, substitute 0.2 into your fx, then you will get this value. Okay, find for each of your I. Okay, I from 0 to 5. You sum up all this value of fxi star and then multiply with your h. You get the approximate solution, 5.182. 7. Okay, so now let's move to the second method for numerical integration, the trapezoidal rule. Okay, so this is a revision of the rectangular rule. So in the rectangular rule, you use the rectangle shape, right? So in this trapezoidal rule, you will use the trapezoid shape. Okay, this is the trapezoid shape. Okay, so areas of all trapezoids are computed. Total area of all trapezoid is the estimation of the area below the curve of the function, okay, which is also the approximate of the integral of the function. There will be a smaller error in this calculation because you will use this shape. In the general form, you get this formula for trapezoidal rule. Okay, look at this example. Use trapezoidal rule with 10 subinterval to estimate exponent negative x squared dx from 0 to 1. This is your A and this is your B. This is table for trapezoidal rule I, xi, and then this is your FA, and this is your FB. FA equal to 1 and FB equal to 0.367879. FA and FB, and this is your the other FXI. Why we write the table like this? Because this FA plus FB, we want to multiply it with half. Look at this. Half FA plus FB and then summation of FXI. So this is the total of FA plus FB, and this is the other FXI, FX1 until FX9 in this case, right here. Substitute the values into the formula. Here, FA plus FB, this value from the table. This is also value from the table. This is your H. Simplify this, then you will get 0.746211. Okay, we have several exercises here. Exercise 3.4, 3 questions. So you can try to do by yourself and then check the solution that I have given here. Okay, let's discuss question number 1. Okay, evaluate 1 over 81 minus 16 x squared power of half dx from 1 to 2 using trapezoidal rule with h equal to 0.1. Then show the exact solution of the integral is equal to 0.158590 using 6 decimal places in calculation. So this is for exact solution. This is the value of the exact solution, and this is the approximate solution from the numerical integration. By using the substitution for x equal to 9 sine theta. Okay, you have this substitution, then you have to find the exact solution. Okay, it's all written here. You can check whether you get the right answer. Question number 2, the trapezoidal rule, I, xi, fa, fb, fx1, fx2, fx3, summation, fa, fb times 2 half plus with summation f1, f2, f3, multiply with your h. Then you get the approximate solution 2.978416. Okay, similarly for question number 3. Okay, the last method for today is the Simpson's rule. For the first method, the rectangular or the midpoint rule, this method will use the constant to estimate the area of each subinterval. In the second method, trapezoidal rule, we use the linear equation to estimate the area of subinterval. So now for Simpson's rule, we will using the quadratic equation to estimate the area of each subinterval. In Simpson's rule, the area of the paraboloid shape will be used to approximate the curve of the function. So this function px, a x squared plus bx plus c. So this method is proven to be more accurate than the midpoint and trapezoidal rule, since it's covered all the areas under the curve. The general formula for Simpson's rule, okay, approximate h divided by 3 fa plus fb 4 times summation of fx in the odd value and 2 times the summation fx even value. we will use the same example, just change the method to the Simpson's rule. Apply Simpson's rule with 10 subinterval to compute exponent negative x squared dx from 0 to 1. This is your A equal to 0, B equal to 1, H is equal to 0.1. Okay, we make a table that will help us to compute the integral I, xi, fa, fb, okay, fx odd, and fx even. So fx odd, I equal to 1, 1, 3, 5, 7, 9. Okay, fx odd. And then fx even 2, 4, 6, 8. Find the total value of each of these and then substitute into your formula. Okay, so this is the general formula. H divided by 3. This is FA plus FB. This is 4 times FX odd, 2 times FX even. Simplify this, then you will get approximate solution 0.746825. So that's all for today.